Bismillahirrahmanirrahim. Quote of the day is if you cannot do great things, do small things in a great way. Assalamu alaikum everyone. I'm Dr. Shajia Javed, PGR Community Medicine, and I'm going to present the topic of mayas of dispersion under supervision of Professor Dr. Saira Afzal. Planning outlines. In today's session, we will have an introduction to dispersion, types of dispersion including absolute and relative mayas, basic mayas of dispersion, range, interquartile range, mean absolute deviation, advanced measures of dispersion including variance, standard deviation, and coefficient of variance, strength and weakness of different measures, and at the end there will be MCQs. Learning outcomes. By the end of this presentation, participants will be able to understand the concept and importance of dispersion, identify the different types of measures of dispersion, calculate range, variance, standard deviation, and IQR, compare different dispersion measures and their effectiveness to interpret the statistical results for decision making. So let's start with dispersion. Dispersion refers to the degree of spread or variability of data points in a data set, or as Bowley defined it, is a measure of the variation of the items. Dispersion means the distance of the scattered data from the mean or the average value of the data. If we consider this graph, the value A is less dispersed as compared to B or C. A higher the dispersion indicates more variability, while a lower dispersion basically means that the data points are closely clustered around a central value. Dispersion helps us understand how much the data deviates from the central tendency, mean, median, or the mode. Objectives of measuring dispersion. To understand the data variability, dispersion determines how spread out the data points are. Compare different data sets. It helps us analyzing which data sets has more variability. Assess the reliability and consistency. Lower dispersion basically means more consistent data. Identify outliers. It detects extreme values that may impact the analysis. Assist in statistical interference used in hypothesis testing and confidence intervals. Improve the quality control to ensure product and processes consistency. And provides basic for the advanced analysis. It supports regression, correlation, and predictive modeling. Properties of good dispersion. A good dispersion is easy to understand, mathematically defined, based on all the observations, independent on the sample size, robust to extreme values, comparable across the datasets, and dimensionally consistent. Now, what are the types of measures of dispersion? The measures of dispersion can be divided into two classes, absolute measures of dispersion and relative measures. The absolute measures are actually the one that provides a value in the same unit as the original data. Examples include the range, interquartile range, mean deviation, variance, and the standard deviation. While the relative measures of dispersion are the unitless measures that compare variability across different datasets. The examples include the coefficient of range, coefficient of variation, coefficient of the quartile deviation, and the coefficient of the mean deviation. The differences between the absolute and the relative measure of dispersion are an absolute measure is the one that uses the numerical variation to determine the degree of the error, while the relative one uses the statistical variation based upon the percentages to determine how far from reality a figure is within the context. Absolute measures measure the extent of dispersion of item values from a central tendency, while the relative measures are known as a coefficient of dispersion. They are obtained as a ratio or the percentages. Absolute measures are expressed in terms of the original units of the series, while the relative measures are the pure numbers that are independent on the units of the measurement. Absolute measures are useful for understanding the dispersion within the context of experiment and measurements, while the relative measures are useful for making comparison between separate datasets or the different experiments. Absolute measures are comparatively easy to compute and comprehend, while the relative measures are comparatively difficult to compute and comprehend. The first measure of dispersion we are going to discuss is range. The range is the simplest measure of dispersion that shows the spread of data by calculating the difference between the highest value and the lowest value in the dataset. The formula is very easy. Range equals to maximum minus minimum value. For the coefficient of range being a relative measure used to compare the dispersion of datasets, the formula includes maximum value minus minimum value over maximum value plus minimum value. Let's consider it through an example. If a data set is given 5, 8, 12, 15, and 20, then to calculate the range, we will put the values in the formula. We simply have to subtract the minimum value from the maximum value. Subtracting 5 from 20, the answer would be 15. So therefore, the range is 15 for that case. If we consider the same data sets, the coefficient of range would be maximum value minus minimum value over maximum value plus minimum value. Let's put up the value. The coefficient of range would be 20 minus 5 over 20 plus 15, and the answer would be 0.6. Merits and demerits of the range. The merits of the range are a range is simple, it's easy to calculate and understand. It's a quick measure and provides a fast idea of how the data is dispersed. It's useful for comparison, help compare variability between the different data sets. The applicable in quality control is used in industry to check the consistency in the production. The demerits of the range include it ignores the intermediate values as it only considers the highest and the lowest values. It also ignores all the other data points. It is sensitive to extreme values. It is affected by the outliers, making it very unreliable for the skew distribution. It's not suitable for the large dataset because it doesn't give a complete picture of variability in the large datasets. It's not a stable measure because small changes in data can significantly affect the change. The second one is interquartile range or the quartile deviation. The interquartile range measures the spread of the middle 50% of the dataset. It's calculated as IQR is equal to Q3 minus Q1. The quartile deviation of the semi-interquartile range is half of the IQR. It shows the average spread around the median. Formula would be QD equals to Q3 minus Q1 over 2. The coefficient of the quartile deviation is relative measure of the quartile deviation, calculated by the formula Q3 minus Q1 over Q3 plus Q1. Now the Q1 is the first quartile. It is a value which is below the 25% of the data falls, and Q3 is the third quartile. It is a value below which the 75% of the data falls. Let's consider an example. If we have a data sets of 15, 24, 27, 28, 30, 20, and 18, the first step would be arranging that data in the ascending order. Once we have arranged in the ascending order, we will have to find the Q1 and the Q3. Since the median in that data set would be 24, the Q1 would be 18 and the Q3 would be 28. Now let's put up the values in the formula. IQR as we discussed is Q3 minus Q1. 28 minus 18 would be 10. QD is half of the IQR, so therefore 10 divided by 2 would be 5. For the coefficient of the range, the formula is Q3 minus Q1 over Q3 plus Q1. After putting the value, the answer would be 0.217. Let's consider the merits and the demerits of the IQR. The merits include it is not affected by the outliers. Unlike the range, IQR ignores the extreme values, making it as a better measure of dispersion. It focuses only on the middle 50% of the data and provides a better understanding of the central tendency and the spread. It's useful in box plots, help to identify the outliers and visualizing the data distribution. It's more reliable for the skewed data and works very well when the data is not symmetrically distributed. However, the certain disadvantages of the IQR, it ignores the 50% of the data. It doesn't consider the influence of the extreme values, which may sometimes hold important information. It is less intuitive than range and requires a calculation of the quartiles, making it very more complex than the range. It's not commonly used as a standard deviation. In some cases, variance or standard deviation is preferred for statistical analysis instead of IQR. Third one is mean deviation. Mean deviation measures the average distance of each data from a central point, mean or median. It helps us understand how spread out the data is. The formula of the mean deviation from mean would be summation x minus x bar over n. From the median, it is often preferred because median is less affected by the outliers. The mean deviation is summation x minus median over n, where x is equal to the data values, x bar is the mean of the data, and n is the total number of the values. Let's consider the systolic blood pressure readings of 5 individuals in a population to be 120, 130, 110, 40, and 150. First of all, we have to calculate the mean blood pressure. Some x bar is calculated by adding all these divided by the total number of the values. The answer would be 650 divided by 5, 130. In the second step, we have to calculate the absolute deviation from mean by subtracting each individual value from the mean. Now, in the third step, to compute the mean deviations from the mean, every value is added and then it is divided by the total number of the values. The answer would be 60 divided by 5 over 12 equals to 12. The merits and the demerits of the mean deviation. The merits of the mean deviation include it is simple to understand, easy to calculate and interpret. It is less affected by the extreme values, especially when calculated from the median. It gives us a clear measure of dispersion, shows the average deviation from the center. The demerits of the mean deviation include it ignores the signs of the deviation, uses absolute values, losing directional information. It's not as widely used as the variance or standard deviation because it's usually they are more preferred one. It is more complex than the range and requires more calculation than a simple range. Standard deviation. Standard deviation is the most important and a widely used measure of dispersion. It's first used by the Carl Pearson in 1893. It's also called as a root mean square deviation. It's defined as the square root of the arithmetic mean of the squares of the deviation of the values which are taken from the mean. It's denoted by the sign of the sigma. The formula is sigma equals to under root summation x minus x bar square over n, or summation x square over n, where x is equal to x minus x bar. The coefficient of the standard deviation is variance over x bar. If the standard deviation is low, it means that the most data points are close to the mean. But if the standard deviation is high, it means that the data points are spread out or a wider range. Formula of the standard deviation for a population is discussed as sigma summation x minus mu square over n, where x is equal to the value of the data in the distribution, mu is equal to the population of the mean, and n is equal to the total number of observation. But if we're considering sample, s equals to summation x minus x bar over n minus 1, where x in that case is the value in the data distribution, x bar is a sample of the mean, and small n is the total number of the observations. Let's consider the standard deviation by an example. Let's say we have the systolic BP of the five individuals and record their reading as 120, 130, 110, 140, and 150. Our first step would be to find the mean. The mean is calculated by this taking sum of all these and then divided by the total number of the values. Let's take sum of all these, that would be equal to 650. Now we will divide it from the total number of the values, that is 5 in that case. The answer is 130. In the second step, we have to find the deviations from the mean. For this purpose, we have to separate the individual value from the mean, which is 130, that is x minus mu square. After subtracting each value from 130, we get these answers. In the third step, we will take the square of deviation x minus mu square. Uh, and in the fourth step, we have to compute the variance. The variance is the average of the square deviation. Formula summation x minus mu square over n, we have to sum all these values and then divided by the total number of the values. The sum of all these values of x minus mu square is 1000, and it divided by the total number of value, which is 5 in that case, would be 200. To compute the standard deviation, we will take the square root of these variance. The square root of the 200 is 14.14. So in that case, the standard deviation is 14.14. Why is standard deviation important? Standard deviation is one of the most important statistical tool because it measures how much data deviates from the average. It helps us in understanding the consistency, variability, and risk in the different fields. It understands the spread of the data and the variability. Low SD means the data points are close to the mean, meaning the data set is consistent and stable, while the high SD mean the data points are spread out, meaning there is a lot of variation in the data sets. It helps us identify the outliers and anomalies. A high SD mean the extreme values or the outliers are existing in the datasets. Detecting the outliers is very crucial in healthcare, finance, or the quality control. For example, if we study measure the systolic BP of the 100 patients, many readings are between the 110 to 140, but one patient has a BP of the 200 millimeter of the mercury. This outlier will increase the SD, signaling a potential serious health condition. Compare different datasets. SD allows us to compare the consistency of two or more groups. It is used in scientific research in the medical studies, helping the scientists understand how reliable their experiment results are. A low SD means consistent, reliable product, while a high SD means unreliable data. It measures the risk using in finance, business, and healthcare. It ensures the quality control, helping the manufacturers produce consistent products, and improves the decision making used in research, sports, and in the industry. Merits and demerits of the standard deviation. The advantages include it measures variability and accurately. It is useful for comparing datasets, important for the risk analysis. It is mathematically reliable. It's applicable in various fields, and it detects the outliers and anomalies. While the disadvantages include it has a complex calculation, it's affected by the extreme values or the outliers, it assumes a normal distribution, it's difficult to interpret in some cases, units of the SD are different from the data, and it is sensitive towards the sample size. Variance. Variance measures how much the data points deviate from the mean. It is the average of the square root differences from the mean. For a population, variance sigma square equals to summation x minus mu square over n. And for a sample, it's summation x minus x bar square over n minus 1, where a capital X is each data point, Mu is the population mean, x bar is a sample mean, n capital is total number of the population from the data points, and n small is the total number of the sample data points. The coefficient of variation is a statistical measure that expresses the standard deviation as a percentage of the mean. It helps us to compare the relative variability of different datasets, even if they have the different units on the scales. Coefficient of variation was developed by the Carl Pearson. It's important relative measure of dispersion. It is used in comparing the variability, homogeneity, stability, uniformity, and consistency of two or more series. Higher the coefficient of variation, lesser the consistency. Formalized coefficient of variation is sigma over x bar into 100. The difference between the coefficient of variation and standard deviation is coefficient is a relative measure of dispersion, while standard deviation is an absolute measure of dispersion. Coefficient of variation measures the ratio of the standard deviation to the mean, while the standard deviation measures how far a data lies from the mean. Coefficient of variation is usually used to compare the variation of different datasets, while the standard deviation is used to measure the dispersion of the data in a single dataset. Merits and the demerits of variance. Advantages include it measures data spread precisely, it uses all the data points for better accurately, it is essential for statistical analysis like standard deviation or regression, it helps us identify the outliers and anomalies, it's used in the risk and performance analysis. While the disadvantages include the units are squared, not same as original data, it is sensitive to outliers, extreme value increases the variance. It's harder to interpret compared to the standard deviation. It can be more complex to calculate and it is less intuitive for the non-statistics. Let's consider it through the example. Given the BP ratings in the millimeter of the mercury of 120, 130, 110, 140, and 150. The first step, find the mean. Add all these values and divide it by the total number of the value. The answer 130. In the next step, find a deviation from that mean, which is x minus mu. These are the values obtained by subtracting it. Now take the square root of the deviation x minus mu bar, which is this. Compute the variance. For a population, it would be summation x minus mu square over n. Add all the values of x minus mu square divided by the total number of the values. The sum comes 1000 divided by the 5, which is the total number of value in that case. Answer is 200. So the variance in that case is 200 millimeter of the mercury. Let's consider the practical example by the article. Taking metformin and cognitive function changes in the older patient with diabetes. The aim of the study was to investigate the effect of the metformin on cognitive function in prospective cohort of the older adults. In the methods, participants aged 60 years were selected and the Korean version of the consortium to establish a registry for the Alzheimer's disease assessment was taken, including the mini mental state examination and the activity of daily living were evaluated prospectively. Rapid deterioration of the cognitive function was defined as the annual change of the test score in the lowest quartile. Result, a total of the 732 participants with a mean age of the 76.7 plus minus 6.6 years were followed up for 2.9 years. Interquartile range 1 to 5.7 years. A linear mixed model shows that the diabetes was associated with a significant deterioration of the verbal delayed recall and recognition score, p-value 0.007 and 0.022 respectively. Among diabetic patients, metformin treatment was not associated with changes of any Korean version of the consortium to establish a registry for the Alzheimer's disease assessment component or the activity of the daily living index. However, the rapid deterioration of the mini mental state examination and the verbal immediate recall scores was more frequently found in the metformin taking group, even after the adjustments. The second article, the prevalence of the pulmonary hypertension after successful TB treatment in a community sample of the adult patients. There are estimated 155 million survivors of the TB. Clinical experiments suggest that the post-TB lung disease is an important cause of the group 3 pulmonary hypertension. A cross-sectional community-based study was conducted in the non-healthcare seeking individuals who have successfully completed their TB treatment. Subjects underwent questionnaire, spirometry, assessment, walk distance test, and transthoracic echography. 100 adults, 71% were male, were enrolled with a mean age of the 42 years, standard deviation 13.8 years, and a median of 1 TB episode, intercontrol range 1 to 2. Comorbidities include hypertension, diabetes, HIV virus, asthma, and COPD. An association was found between the pulmonary hypertension and the number of the previous episodes, with each additional episode of the TB increasing the odds of having pulmonary hypertension post TB by 2.13 fold. Confidence interval 1.17 to 3.88. Now let's move towards the MCQs. MCQs number 1. A company calculates the standard deviation of the employees' salaries. If the standard deviation is high, what does it indicate? A. Salaries are close towards the mean. B. Salaries are widely spread out. C. Salaries are equal. D. There is no dispersion. E. The salaries are not spread out equally.
B.
B. B.
B.
Yes, the correct. Yes, the correct answer is B. MCQ number 2. Which measure of dispersion is least affected by the extreme value? Option A, range. Option B, standard deviation. Option C, interquartile range. D, variance. And E, mode.
Interquartile
C.
range. C.
Quartile.
Yes, C, interquartile range is the correct option. Number 3. A company has a two branches. Branch 1. It has a salary at a standard deviation of the $500, while the branch 2 has salaries having a standard deviation of $200. What can be calculated about the salary dispersion? A. The salaries in the branch 1 are more consistent. B. The salaries in the branch 2 are more consistent. C. Salaries in both branches are equally dispersed. D. Standard deviation does not measure salary differences. E. Salaries are less in one branch as compared to the second branch.
B.
B.
Yes, B is the correct option. Number 4. A professor finds that the interquartile range of the students is 15. What does this interquartile range represent? The difference between the highest and the lowest score, the range of the middle 50% of the score, the average score of all the students, the highest score in the datasets, or the range of the middle 25% of the score.
B.
B. Middle 50%.
Alpha.
No, beta is the right option. Number 5. A teacher calculates the standard deviation of the two groups. Group A has a standard deviation of 8, while Group B has a standard deviation of 3. What does this indicate about the student's score? Number option 1. Group A scores are more consistent than Group B's. Option B. Group B scores are more spread out than Group A. C. Group A scores are more spread out than Group B's. D. Both groups have the same consistency in scores. E. There is no relation between the scores of the two groups.
C.
B.
C.
C.
The ans- the answer is C. Group A scores are more spread out than the Group B. 6. The range of a daily sales of a store operating in Lahore is about to be $500. What does this tell us? A. The store earns a fixed income. B. The lowest sale is 500. C. The store scales are normally distributed. D. The median sales are 500. E. The difference between the highest and the lowest sale is 500.
E.
E. E.
Yes, E is the correct option. Number 7. A student test scores are 50, 60, 70, 80, and 90. What is the range? Option A 50, option B 60, option C 40, option D 30, and option E 70.
C. Charlie.
Yes, Charlie is the correct option. For range, we have to calculate, subtract minimum value from the maximum value. So subtracting 90 minus 50, the answer is 40. Number 8. A data set has a value of 2, 5, 7, and 10. What is the interquartile range? A 6, B 7, C 9, D 2, E 5.
E.
Yes, E is the correct option. First,
I.
arrange the datasets in the ascending order. Then we have to find Q1 and Q3. Q1 is the median half of the first, it is 3.5. Q3 is the median half of the second, it's 8.5. IQR formula is Q3 minus Q1. Subtract 8.5 and 3.5, the answer is 5. So the correct option is E5. MCQ number 9. A data set has a variance of 64. What is the standard deviation? A 6, B 8, C 10, D 12, E 14.
B.
B.
Yes, the variance is 8 because standard deviation is square root of variance. Number 10. If all the values in the data sets increase by 10, what happens to the variance? A. It increases. B. It decreases. C. It remains the same. D. It becomes 0. E. It gets multiplied.
C.
C.
Yes, C. It remains the same. This is the key to MCQs. The link to our YouTube channel where all the presentations are uploaded. Thank you.
Madam,